Hi friends, welcome to Mathematics and Statistics. We'll be going forward with the linear programming. This is chapter 6, part 1. Different books have different chapter numbers depending upon the state board, CPSC and the other boards. Mastering with PYK, class 12 commerce. So we did the concepts in the last part. We'll revise to solve the further problems. So by definition, linear programming is a technique or a concept for finding minimum or a maximum solution, which is also known as optimum solution to a linear objective function. So objective function could be to minimize, maximize, right? Under a certain restrictions or a constraints or a boundary. In real life, we call them our limitations. It can be anything depending on your investment, money, time, working hours, labor, availability of raw material, anything with two or more variables. But in the series, we'll be going with only two variables and we'll be not talking about any negative quantity, right? So going ahead, linear programming, it is a concept, technique, right? And here the objective linear function is denoted by z. So z is ax plus by, and in some cases you can also have some constant which can be represented by c depending on the question. Optimum solution has to be found out. So when we talk about maximizing, so maximize profit, efficiency, sales, marks, manufacturing, production. Minimize cost, wastage, your travel time, your route time or the travel route. Certain restrictions or the constraint which has to be always there. Since we will be dealing with non-negative, so it has to be greater than or equal to 0. And the variables would be 2, x and y, right? So optimum feasible solution means any point in the feasible region. So there will be a region, right? There can be a region. Say this is my graph which comes out of solving. So this is my region, right? So this is a region which can have n number of solutions. But optimum solution would be 1. Say this is the point x over here where we will be getting the maximum or a minimum required. So let's understand with examples. So question 1, we have to maximize z, which is represented as 3x plus 4y. So this is your linear objective function. Constraints are x plus y has to be less than or equal to 4. And since we will be dealing with non-negative, so it is x greater than or equal to 0 and y greater than or equal to 0. So variable x and y, right? And the linear objective function has to be defined. Variable can be 0 or positive, but they will be not negative. We have to find the feasible region first and then the maximum or the optimum solution. So here we have been given x plus y is less than or equal to 4. To solve, what we will be doing is that we will be changing this inequality into equality sign. So how do we do it? We will be doing it by the intercept. So when x is 0, so y would be 4, and when y is 0, x will be 4. Also, we know that both the constraints can be 0. So x can be 0, y can be 0, right? So feasible region, we get 3 coordinates. One was 0, 0, second one was 0, 4, and the third one was 4, 0. Right? So representing it graphically, say this is a graph wherein these are my coordinates. So origin 0, 0, 0, 4 and 4, 0. So how do we reach the optimum solution? That is maximizing c. So we start with each coordinates, right? So we have 3 coordinates. We will be representing it in the equation. So when we solve it by putting the values, we get z is 0 because 0 and 0, it remains 0. So when x is 4, so it becomes 3 multiplied by 4. The y quantity becomes 0, so it is 12. And when y is 4, x is 0, so it's z 0 plus 4 multiplied by 4, which comes out to be 16. So seeing this is my feasible region, and the optimum solution, since it is to maximize, is 16. So we represent it saying that the maximum value or the optimum solution is 16 at 0, 4 for the given condition. Question 2 says minimize. So we have been given a equation z as minus 3x plus 4y subject to two conditions here. Right? It says that x plus 2y is less than or equal to 8 and 2x plus 3x plus 2y is less than or equal to 12. The other constraints are explicitly given, greater than or equal to 0. This number can be any number but not negative. It can be 4, it can be 3, it can be anything, right? So we solve, we have the variable x and y, right? And the linear objective function is given. Variables can be 0 and positive but will not be negative. We have to find first the feasible region and then minimizing or optimizing the objective function. So we'll convert these equations into the equality equations, and on solving, right, what we will get? We will be doing subtracting both the equations from one another. So this will be left with, this will get cancelled. This will be minus 2x and minus 4. So this is what we get at the end. So solving, we get x is 2. Putting the value of this in equation 1, we get y as 3. Right? So this is our first equation. Also note, we can have both the values as 0. Right? So this is the equation which we get. 3x plus 2y less than or equal to 12. Right? So when we put the values, right, we will be getting 3 points. Why 3 points? Because we will be also finding the intercept by putting x as 0. So when x is 0, y will be, so here when we say intercept, so we'll be putting in equation 1 x as 0. So y will be 2y is equal to 8 and then y would be 4. Right? So this comes this way. X plus 2y is 8. 3x plus 2y is 12. Right? We solved it and we got the two equations. So feasible region would be 2, 3. And from equation 1, when we put x as 0, we get y 4. And y as 0, we get x as 8. Similarly, in equation 2, this equation, x is 0, so 2y will be 6, 2y becomes 12, so y becomes 6. And similarly, when y is 0, 3x becomes 12, so x becomes 4. Right? So we have these equations and the origin, because at any point of time, x and y can be 0. Right? So to find the optimal solution, we will be finding the value based on each coordinates. So we have 1, 2, 3, 4, 5 and 6. Right? So when x is 0, we get z as 0. Right? When it is 4, 0, we get z as minus 12. Right? And when it is 0, 4, z is 16. 8, 0, it is minus 24. And 0, 6, it is 24. Right? Now, why this 8, 0 is not been considered? In this equation, if you see, my feasible zone lies between this area. So if I represent it as O, A, B and C. Any region, this value lying in this region or this region is not in the feasible zone. So that is the reason anything here and beyond 4 is not in the region, and anything between 4 to 6 is not in the region. This means I will ignore the values minus 24 and 24. So you will be not calculating them. Here we have only calculated to show and understand the feasible region. Right? So we'll have 0, 4, 2, 3 and 4, 0 and 0, 0. Right? So we will also have to calculate for the value at 2, 3. So when we put this in 2, 3, which I have not done, you will be doing in your practice notebook, we will be getting minus 6. 2 3s are 6, right? And 3 4s are 12. So it comes out to be plus 12, right? So this is 6, right? So out of the 4 values, the minimum value would be minus 12. So our accepted value or the optimum value is minus 12. So please be specific when you are finding the region. Don't calculate anything beyond the feasible region. And if it gives you value, you have to ignore that. We'll be only considering the solutions lying in this region. Right? So the answer is the minimum value is minus 12 and it is obtained at coordinates of 4, 0. Let's understand with more examples. So what happened? In the previous example, we have seen that there were 3 coordinates 0, 4, 4, 0 and 0, 0. So these 3 coordinates represent the possible solution. And when we represent it and calculate the value for each of these coordinates, right? For each of these coordinates, we get feasible solution. An optimum solution would be depending on the requirement. Say it was maximum value, so it is 16 and the coordinates of the focus are 0, 4. This is known as optimum solution. Right? The solution can be many. Feasible region would be arrived at, and then based on the feasible region, we will be having the optimum. Right? So we work on the corner point method or a convex polygon theorem. Right? What it says? Let's understand step by step, or let's understand the algorithm of this theorem. It says that the optimum solution to the linear programming problem will be at the corners of the feasible region. Right? So step 1, what we do? We convert all inequalities into the equal equations or the equality to solve. Then we draw the xy plane, x-intercept and y-intercept. This means we put x as 0, find the value of y, we take y as 0 and find the value of x. Then we find the feasible region for the linear programming problem. So anything beyond the feasible region, we will be not interested in calculating the values. Based on the coordinates of each vertex, we will be solving the equation. Right? So at each vertex or the corner point, we'll be computing the objective function. So this is how we did. Then we'll identify the corner points where the z is maximum or minimum depending on the linear programming. So based on this table, right, we will be computing the minimum or maximum and we will be defining that as an optimum solution at the defined coordinates. So here it is 0, 4 are the coordinates where the LP has the maximum value of 16. Right? So this becomes our optimum solution or an optimal solution. If it is minimum, we will be using the minimum value and the coordinates accordingly. Right? So this is represented as Z, which is also known as optimum value. Right? So let's understand what is a feasible region. It is a set of points which satisfy all restrictions or the boundary conditions or the constraints. Feasible solution, it is any point which gives me a maximum or a minimum value depending on the objective function. So region can be, say if this is my graph, right? So there can be, okay. So this is my feasible region, right? And we'll ignore anything beyond this, right? And there would be only one point, right, which will be available either as a maximum or a minimum solution, right? So assuming this was our table again, right? So what we did, we represented the coordinates and calculated the value of z, that is the linear objective function, and found out our answer, right? So we had 3 points O, A and B, right? And the feasible solution was obtained as 16 at coordinates 0 and 4. So see you in the next part. Keep practicing. So education is the passport to the future. For tomorrow belongs to those who prepare for it today. Keep practicing. All the best. Bye-bye.